Welcome to this video. In today's session, we want to look at physics. So we have a question today on the board. So the question reads, figure B1.1 shows a velocity time graph of a car of mass 1,200 kilograms. So this is the graph, that is the velocity time graph that we have. The first question says, define the term acceleration. 1 mark. So what is acceleration? So let's define acceleration together. So part A says define acceleration. Acceleration is simply the rate of change of velocity. So acceleration is a value that indicates how the velocity is changing as time also changes. So we can simply say acceleration is the rate of change of velocity. So acceleration is simply the rate of change of velocity. Some students can also write acceleration is the change of velocity with time. Because when we just say acceleration is the rate of change of velocity, we've already included time in that. So what do we mean by is the rate of change of velocity? It can be represented by a formula that you need to know. So acceleration is basically equal to the change in velocity. I'll use this to represent change, delta. So the change in velocity over the change in time, that is acceleration. Meaning, if I have two velocities, one called the initial velocity and one called the final velocity, delta V represents the change in velocity, which could be the final velocity. We use the symbol V for final velocity, minus the initial velocity. So this gives you the change in velocity. Then we divide everything by the change in time. So this is the formula that you need to be using when you are asked to find the acceleration given two velocities and the time taken to change to a particular velocity. So that is what we basically mean by acceleration. Acceleration is the rate of change of velocity. Apart from that, you also need to know that the units used for acceleration are meters per square second. So you probably see this as m/s squared. Meters per square second. Meters per second squared, if you want to read it in that way. Acceleration is a vector quantity, so you should also take note of that. Meaning it has a value and direction. When we say vector quantity, we mean any quantity which has both magnitude and direction. So acceleration is also such type of a quantity. So acceleration is a vector quantity. What are the units for acceleration? Meters per square second. How do we define acceleration? It is simply the rate at which the velocity changes. Or someone can just say acceleration is the change in velocity as time changes, or the change in velocity with time. That's all. We go to part B. Part B says calculate the acceleration of the car in the first 3 seconds. So if we take a look at the graph tells us something about this car. The first part of the journey happened in the first 3 seconds. So you can see that what's happened in the first 3 seconds is that the car moved from a velocity of 0 meters per second to a velocity of 30. And it took 3 seconds. So in the first 3 seconds, the car was accelerating. Why? Because the velocity was changing. As long as there's change in velocity, as long as we're able to see that the velocity is changing as time changes, we say that the body is accelerating. Acceleration can have 3 values that you should know. Acceleration can be positive. When the acceleration is positive, it shows that the body is speeding up. Velocity is increasing from a less value to a greater value. Acceleration can also be negative. So positive, you see a graph like that. It means that the acceleration is positive, meaning the velocity is increasing. When the acceleration is negative, it means that the body is now slowing down. Sometimes when you apply the brakes, maybe you are speeding up, then you apply the brakes, you see that the motion of the car goes to a stage where the body begins to slow down. It means that the body now has negative acceleration. So here the velocity is slowing down. You will see something like this. Apart from that, acceleration can also be 0. When the acceleration is 0, it means that the velocity was constant. It was not changing, meaning it wasn't reducing or increasing. It was just constant. It stayed with the same value. That is when the acceleration is said to be 0, when the velocity is constant. So there are three values that we could have. A positive value to indicate that the body is speeding up. A negative value to indicate that the body is slowing down. And 0 to indicate that the velocity is constant. When the acceleration is negative, we have a special name for this type of acceleration. We call this deceleration. Okay. So that is the term that we should assign to such type of an acceleration, deceleration. So when you say that the body is slowing down, we say the body is decelerating. Apart from that, we can also say the body is retarding. So retardation or deceleration, these are terms that we use interchangeably. So if you look at the graph again, you can see that in the first 3 seconds, the body was accelerating because the speed was increasing. That is the type of the graph that I talked about. Between 3 seconds and 8 seconds, you can see that the velocity is no longer changing. It's not going down and it's not going up. So what's happening here is that the body is having a steady velocity. The velocity is not changing. What do you mean? We mean that the acceleration there now is 0. So when the velocity is constant there, then the acceleration is 0. We know that there is no change in velocity. In the last part of the journey, in the last 2 seconds, you can see that in the last 2 seconds here, the graph is like this. You can see that the body is now slowing down. What is happening to the body there? The body is decelerating. The graph is a straight line here, meaning the acceleration is constant. The graph is also a straight line there, meaning our deceleration is also constant. How about in the middle there? The graph flattens. The flat line there shows that the velocity is constant. In other words, the acceleration is 0. So with that being said, let's continue answering these questions together. So the second question says we need to find the acceleration in the first 3 seconds. We already know how to find the acceleration. So part B, find the acceleration in the first 3 seconds. We're going to write down this formula. Acceleration equals V minus U over T. Then we're going to collect our data. What is our V? The final speed, the final velocity rather, V is the final velocity. You can see that in the first 3 seconds, our final velocity is now at 30. So 30 is what we're going to use as our V. U is the initial velocity, the velocity the body started with. You can see that the body was initially at rest. When we say the body is at rest, we mean the velocity is initially 0 meters per second. So the velocity was initially 0. So we know that our U is 0. So, and what time did it take? It took 3 seconds to move from 0 all the way up to 30. So time taken, 3 seconds. So with these values, we just need to substitute in the formula there and find the acceleration. So our acceleration will be equal to V is 30 minus 0 divided by 3. So you can see that our acceleration will be 30 over 3. When we divide here, our acceleration will be 30 divided by 3 is 10. So we have 10 there, but do not forget the units. So what are the units for acceleration? Meters per square second. And you get your 2 marks there. Part B says, B2 now, calculate the force, the net force acting on the car in the first 3 seconds. So for this body to accelerate, there must be a net force, there must be a force that is making it accelerate. This is in accordance with Newton's second law of motion. So according to Newton's second law of motion, the acceleration of the body, A, is actually directly proportional to the force that is acting on it, but inversely proportional to the mass of the body. This is what we call Newton's second law of motion. The acceleration of the body is directly proportional to the net force acting on it, but inversely proportional to the mass of the body. This is logical. If I increase the force that is pushing a particular body, we expect that body to speed up. So we expect the body to increase its velocity. The body will be accelerated. If the mass is increased, if something is heavy, we expect something to move slowly. So you can see that if you want to have an increased acceleration, you should have an increased force. And if you want to reduce the acceleration, you should increase the mass. So acceleration is directly proportional to the force, but inversely proportional to the mass. This is Newton's second law of motion. We write Newton's second law of motion with the help of an equation. It is written as the net force is equal to ma, where m is the mass of the body in kilograms, and a is the acceleration of the body in meters per square second. So using Newton's second law of motion, we can work out part B2. So F is what they are asking us to find, because they are saying the net force acting on the car. So the mass of the car was given in the question. If we read the question together again, we can see that the mass of the car is actually 1200 kg or 1200 grams. So we know that here we have 1200 kilograms multiplied by our acceleration. In the first 3 seconds, we've already calculated the acceleration, 10 meters per square second. So we have 10 meters per square second here. What do? This is just mathematics now. We simply multiply. So net force is equal to, when we multiply that, we're going to have 12,000. Because this is a force, the units for a force, newtons, capital letter N. And that is how it's done. We go to part C. Part C says, explain why the acceleration of the car, supposed to be car here, explain why the acceleration of the car between 3 seconds and 8 seconds is 0. So explain why the acceleration between 3 seconds and 8 seconds is 0. We explained this already. We know what's happening there. So why is the acceleration 0 there? The acceleration between 3 seconds and 8 seconds is 0 because the velocity is constant. That's all. Because the velocity is constant. You can as well prove this. We know that acceleration is v minus u over t. So between 3 seconds and 8 seconds, it's like the car starts at 3 and moves all the way up to the 8th second. So when time is 3, we see that the velocity is 30. So my initial velocity is 30. When it moves from 3 to 8, the velocity does not change. The velocity is still 30. So it's like the final velocity and the initial velocity are all equal to 30. Meaning that we are going to have 30 minus 30. What time has been taken to move from 3 to 8? We can subtract 8 minus 3, 5. So you can see that we're going to have 5 there. But the numerator there, 30 minus 30 is 0. Meaning overall, this will give us something which is equal to 0. You can see that our acceleration is indeed equal to 0. Why? Because the velocity is constant. So explain why the acceleration is 0 there. The acceleration is 0 because there is no change in the velocity. In other words, delta V is 0. Remember, I said delta V is simply our change in velocity. So that is why the acceleration is 0 there. So you could tell the examiner here that the acceleration is 0 because the velocity is constant. The velocity of the car is constant between 3 seconds and 8 seconds. That's what you're supposed to say. Part D. But this says calculate the displacement of the car for the whole journey. So find the displacement of the car for the whole journey. When we talk about displacement, we mean the distance that the car covered in a particular direction. Displacement is simply the distance covered in a particular direction. That is displacement. So in other words, we just want to find the distance that was covered in some direction here. If you are given a velocity time graph, students, you are given a velocity time graph and you are asked to find the displacement of a particular body. All you need to do is find the area formed under the graph. Let me just illustrate something using this body here. So if I have a situation where a particular body moves from a velocity of 0, it goes all the way up to 10, and it does that in 5 seconds. And I'm asked to find the distance covered. I just need to look at the area of the shape which has been formed by that journey. So if I look at this, to move from 0 to 5, I have formed a particular shape here. I have formed this shape. We all know that this shape is a triangle. When we find the area of this triangle, it's as good as finding the displacement covered by this body. So how do we find the area of a triangle? We know that area is simply half BH, where this is the base and that is your height. So if you were to find the area of this, you would have found the distance covered. So you need to be familiar with some shapes like a triangle, a rectangle, a square, a trapezium. Those are the common shapes that you basically see when it comes to solving such questions. So if I have something called a trapezium has this shape like this, or it could be like this. That's a trapezium. So we call this a trapezium. A trapezium has two parallel sides which are separated by the distance h. So the two parallel sides can be given names like A or B. So it doesn't matter which one you choose to be your A, which one you choose to be your B. It still comes back to the same thing. Then the distance between the parallel sides is the height h. Just like here, A, B. Sometimes we could have, this one only has one triangle, but sometimes you could also have that. It's still a trapezium. As long as you have two parallel sides and there's a perpendicular height. This height is 90, making a 90 degrees there. So this distance between the parallel sides is what we call the h. So when you find the area of, if a journey formed such type of a shape, we call this a trapezium. So to find the distance covered, we just need to find the area of the trapezium. But how do we find the area of a trapezium? A trapezium has its area given by this formula. A equals half multiplied by A plus B. You add the two sides, then you multiply by the height. That's how you find the area of a trapezium. You just need to know how to find it. Remember, we also have other shapes like a rectangle, has the length and the breadth there. To find the area, you simply need to multiply A or B. Square, just like that. You just need to look at the shapes and know how to find the area of such shapes. So in today's video, what we have here is a trapezium. So we're going to use this formula to find the area, and that will give us the distance covered in the particular direction. So let's do that. So if I look at I will do it here because I have some space there. If I look at my diagram here, I want to find the distance, the entire distance covered, meaning that shape which has been formed is a trapezium. You can see that if they said find the distance covered in the first 3 seconds, you just look at the first 3 seconds and say, oh, this is a triangle. You just need to find the area of the triangle. Sometimes they'll say find the distance covered in the last 2 seconds. That's a triangle. Sometimes they'll say find the distance covered when the car was not accelerating. Where is the car not accelerating? Between 3 seconds and 8 seconds. So meaning you just need to find the area of this rectangle, L times B. Super easy. But in this case, we want to find the total distance covered. So that is the area of the trapezium. So part D. So the distance covered here is simply equal to the area. And this area is equal to half A plus B multiplied by H. So our distance, remember we are finding displacement. We use the symbol S for displacement. So usually, sometimes you would see S for speed, depends on the context. So here, I'm using S to mean displacement. So the displacement covered. So half. So our A will move from there to there. Remember we said it doesn't matter which one you choose to be A, which one you choose to be B. So from there to there, you can see that the distance is simply 10. So from there to there, it's 10. So my A is 10. Then B is from there all the way up to there. So you can see that here we have a 3 and there 8. So the distance between them is 5. So B is 5. So this is 5 units long and that is 10 units long. So we have 5 there. Then the height is the distance between the parallel sides, which is this simply 30. Remember we had 30 here. That is 30 there. So that is 30. Then all we need to do here is simply open the bracket, simplify further. So 2 there, 1, 2 there, 15. But these are adding. Then once they add, they are multiplying 15 there. So what I have is S equal to, when I add this, I'm getting 15. So it will be 15. What do I have there? 15. So I have 15 multiplied by 15. So my S equals 15 multiplied by 15 is 225. So I have 225. The last thing is to add the units there, the correct units, because this is displacement. Displacement is length. We're talking about length, and the SI units for length are the meters. So what I have there, I'll say meters. So that is how you do it. And that is all for this video. Thank you for watching.